Hello, everybody. Good morning or good afternoon. Well, thanks for joining today's webinar of RhinoLands. Today's webinar is organized in collaboration with the Portuguese Association of Landscape Architects. So I appreciate their efforts in organizing this session and their kind support to technology. So my name is Elham Gabouli. I'm going to present you the first part of this webinar, which is a general overview of the program. And then my colleague Francis Saya will continue with the live demo showing the functions of the program during the live session. RhinoLands is a BIM standalone solution for landscape architecture. This program specifically designed for landscape architects, and this is the difference, the big difference of this program with the rest of programs in the market. Let's see the first part, which is the general overview. The program is a BIM program, so it helps us to produce a 2D drawing, technical drawings. The 3D model of the landscape at the same moment is linked with 2D. It automatically generates the list of plants and other materials of the project, and there are several tools for visualization of the project. RhinoLands is a standalone program, which means that it already includes Rhino for those of you who know who's Rhino. So RhinoLands is Rhino plus Lens Design, which was a plugin of Rhino, and now they are combined in a simplified interface specifically designed for developing a landscape project. So it starts from drawing, then modeling tools, then terrain tools, which is topography, vegetation and hardscape, irrigation, as you see, documentation tools, and then there are several tools for visualization, including Rhino Render. The program is used for landscape architecture, for green infrastructure design, used by civil engineers, for urban planning projects, and for environmental projects. We can easily model a forest by using the program. Let's see its main features. First of all, the program includes an extensive plant database with more than 8,000 plant species. The plant database includes several filters to select adequate plants based on different characteristics, soil type, climate, and so on. Any plant species includes several blocks which help us to use them in different display modes. And there is a realistic 3D model which includes seasonal representation and seasonal change of the project. As you see, we can switch between different displays and in different representation or different displays of plants. As you see, elevation, like conceptual and so on. And in realistic, we can switch from one season to another and see how would be this landscape during different periods of the year. And in this way, we have a clear understanding of our landscape. Well, the 2D and 3D are linked together, so we can switch between them. And as you see, in 2D, we have different blocks, and in 3D, as you see, there are realistic plants. For inserting plants, there are different ways. We can insert them individually. We can move the mouse on the plot and insert them randomly, just for rapid site production. We can convert points to plants, or blocks like AutoCAD 2D blocks can be converted to a realistic 3D plant when we open that AutoCAD file into RhinoLands. Okay. Then we can draw a line or a row of plant species with different combination of plant species, or generate a group of plants, again, by indicating the distance and combination of species. We can insert a group of shrubs by indicating the number of units per square meter or per linear meter. And in the same way, we can insert ground covers, which are small plants used per square meter. Inside of our plant database, there is a plant editor add-on, which is a free add-on. So help us to modify an existing model of plant species and change, for example, its characteristics or its flower color and so on. There are powerful terrain modeling tools that help us to generate a terrain by using points and lines, and then modify the terrain doing different types of operation like cut and fills, create a path on the terrain, dividing the terrain, and so on. The program calculates all earth-moving operations automatically. We can convert point clouds to terrain or import a terrain just by indicating the location on the map. The program will produce that automatically by using a global elevation database. Well, in a simple way, we can compare two different operations on the same terrain. Since there are several tools for terrain operations, we can apply operations in parallel mode and then compare the result of dig and fill volume of these operations and choose which option would be more sustainable or more economic. We have dynamic documentation tools that help us to produce documentation, adding labels of plant species, the number of plant species in each part or in each sector, adding the image of plants, producing different types of dimension plans, and so on. And also in the similar way, in the same way, we can produce different sections, different plans, like conceptual plans, and so on. And also, we can achieve the list of all materials that we have used during the design process of the project. But there are parametric hardscape tools, including walls or edging, which are parametric paths, parametric stairs, parametric ramp, and parametric fence. Also, there is a block library for furniture inside the program. As you see in this example, we see that well, the blocks are parametric, but of course we can indicate the thickness and the height of these blocks and also the material. There are tools for irrigation system. There are 2D elements, so we can design the pipes and locate the sprinklers or drippers in our project. The program automatically lists the pipes and the sprinklers that are used during the design step. For visualization, we can walk mode. We have sun and shadow tool, which help us to visualize how would be the sun movement or shadow movement of our project during the daytime and in different periods of the year. You just need to indicate the location and the north of your project, and then by moving the slider, you see that how shadow is moving in your project. We have also render options, which is Rhino render and additional renders that are compatible. And there's an image filter inside the program. Well, without using any external rendering engine, this is the result that we can achieve by using Rhino render, the internal render of the program. But in case that we want or we prefer to use a more powerful rendering engine, these are the examples of the connection. So we can see that how would be the project by using Enscape, Twinmotion, V-Ray, or Lumion. All of them are compatible with the program. The animation that you see here is made by using Enscape as a rendering engine, but the model is made by using RhinoLands. So in this way, we can bring our ideas and our imaginations to life. Well, another feature is that the program includes parametric design potential by using Grasshopper. So there's a free add-on of Rhino, as you know, or you may know. So we apply Grasshopper to generate a geometry like what you see in this image through linking through algorithms, basically, or we link data to an existing BIM geometry and do different types of analysis. We will see an example later. So these are Grasshopper components of the program. Of course, this is an advanced level. It is not necessary for everybody to know that, but in case that you are working on more advanced projects, you may need to explore a little bit about Grasshopper. Let's just see a simple example of using Grasshopper as a parametric design tool. We are going to place first a bunch of plants with different plant size, and then we apply some algorithms to generate plant pots with the same diameter of any plant species. So there is just a specific definition for that. And by using that definition, automatically these pots are generated. By moving plant species, since they are linked with plants, so the plant pots are also moving. This is a simple example, but we can imagine that there are unlimited possibilities of applying parametric design tool, and in the case of RhinoLands, Grasshopper, to generate and to automate our design steps. So for environmental analysis, which is another example, another feature of the program is that we can link environmental data through Grasshopper to a BIM model in RhinoLands. So imagine that we have a landscape generated in RhinoLands. We can link that landscape to external environmental data. In this way, we made and we have published a carbon calculator, so we can calculate how much carbon will get sequestrated by implementing this project in different periods of time, in 10 years, in 20 years, and so on. How much would be the cooling effect of plants on the surface by linking this model through Grasshopper to Ladybug tools? Or shadow analysis. We can do a shadow analysis. How much would be the coverage of the surface by coverage of shadow coverage on the surface? Or we can calculate solar radiation. So we can calculate how much solar radiation will get absorbed by plants. This is a sample of carbon sequestration calculator. We have a landscape modeled in RhinoLands, and in the right side, we see that this is the carbon calculator in Grasshopper. And this calculator is available and is published. It's free. So we indicate the age of plant species and we indicate the period of calculation. So we see that how much carbon we'll get as the final result will get sequestrated in 10 years or in 20 years or any period of time. Okay. Another feature is that we have BIM workflow. This is a BIM software. So we can open the model inside Revit, as you see, by calling on the category of objects. We can call them and we can import them as a BIM object, and Revit will recognize them as a BIM family. Also, we have IFC support. So let's see how would be the design process by using the program. If we have topographic contours, we can elevate them with a specific command and generate a terrain by using those elevated curves. Alternatively, we can import a terrain by indicating the location of the project on the map. Once the terrain is generated, we apply different operations like cut and fills, create a path, and so on. We can create a boundary of the terrain. And in addition, we can add hardscape objects like walls, fences, ramps, and so on. As you see, they are parametric, so we indicate the distance or the size of elements in a fence or in a stair or in the wall. After hardscape stage, we can continue by placing furniture. And so there's a block library inside the program, but the program is compatible with other formats like SketchUp or other file formats that you prefer and are popular in the market. So we can import those blocks also into the model. And continue, we add vegetation. And as you see here, we open the plant database, select the different plant species that we prefer. We indicate the size of these plant species, and we can work in 2D or in 3D environment. So you can even work all the process in 2D environment. And then when you switch to 3D, you will see that the project is actually a 3D project. So we add labels and produce different documentation of the project. Continue. For example, we can add the image of plants or insert the list of plants, material, earth moving, furniture, walls, and so on. When we switch to 3D, we will see that how would be our project. We can switch to different seasons of the year, so we can see how would be the project in summer or in winter. And finally, we can shot a render and see how would be the final result of the project in real life. Okay, so this is the workflow. Basically, RhinoLands includes everything for drawing, 3D, and documentation. But in case that you have a drawing coming from any other CAD program like AutoCAD, SketchUp, or any other programs, you can open them directly into the program and continue working on its 2D and 3D inside RhinoLands. For visualization, you can apply a render which is compatible, like Enscape, V-Ray, Twinmotion, or Lumion, or you can apply a virtual reality headset to visualize the project by using this technology. Or you can print your project with a 3D printer. For documentation, you can export data or export lists to Excel or PDF, or generate layouts directly inside the program. So you will have different layouts there. You can have collaboration with other programs like 3D Max, Revit, SketchUp through IFC, or in the case of Revit, through Rhino inside Revit technology. And if you have geographic data like GIS files, digital elevation models, BIM files, or point clouds, LiDAR point clouds, you can open them directly into RhinoLands and generate a terrain by using those files. So you can do the whole project with RhinoLands. As you see, you can produce different types of plans by turning on and off different layers and produce different sections. And also you will have a 3D realistic result. This is a real world application of RhinoLands, which is a project in Madrid. This is another real world application of the program, which is a project in Miami, a climate responsive school, which is designed by using the program. So they predicted different periods of the progress or the development of the project, and how this landscape will help to control the flood and the rainstorms of that area. Well, just in summary, there's a 60-day free trial of the program. There are two types of licenses, the permanent and subscription option. So you can choose between them. You will have free technical support from our team, and there are educational and lab licenses at a very reduced price, ideal for students and teachers. And you can take a look at our project gallery to see different examples of how they have developed their project by applying the program. I don't know if we have any questions up to now, or we can continue with the second part. No, so yeah, Francis, you can continue.
All right, thank you very much, Elham. I will take over here.
Sure.
I guess you already see my screen.
Yeah.
Do you?
Yes.
Great. So, well, basically, I will show what Elham has described in this nice presentation, but with a live demo. So those of you that have tried or used Rhino habitually, maybe are familiar with this new interface. But basically, this is like a simplified interface of Rhino with land design plugin, and as we have renamed as RhinoLands. Okay, so you can find here all the necessary tools to draw in 2D, from rectangles to more complex 2D shapes. Same for the 3D geometry, from boxes to torus to spheres, anything that is required to work with 3D geometry, and all the necessary commands to edit them. Even though this is a selection of maybe the most used commands for modeling 2D or 3D, just by typing here any command in the command line, so you will find here all the available tools that exist in Rhino, but also in here, even though they don't have their own icon. Okay. Then we can find here some terrain modeling tools for importing from the web or from GIS or DEM files. We can find here all the tools regarding 3D elements, smart elements such as plants, that can be arranged, as we have seen, in rows, in forests, individually. We can create them from blocks, from points, right? We can find here also the 3D hardscape tools to create parametric walls, fences, stairs, ramps, paths. Okay. Also, we can arrange elements from a library in a row, or we can just pick any block or geometry we have in the model to do these arrangements. We can find here the irrigation tools. Next, we can find the documentation tools from the commands that helps us to generate lists of the objects in the scene to those that are necessary to document for dimensions, okay, or to work in a pitch layout. Those of you that maybe are familiar to AutoCAD, RhinoLands also has this model space and pitch layout space where we can prepare, the 2D drawings of the final model, and where we have this kind of windows to the model space where we can show one view or another. Okay. And finally, we have here some some other visualization commands, selection commands to select objects by type. But I want to show you here this layers panel. Again, this is also a similar tool that we can find in AutoCAD to organize the geometry by layers, so we can switch them on or off. We can assign attributes, materials, line types, sprint widths, etc. Okay, from this dialog. So you will find it very easy to use also in RhinoLands. And also here we have some panels open, for example, this edit panel from where we will be able to edit everything that we have in the model, okay? Along with other panels like the properties, materials, the sun panel to run some kind of analysis, sun shadows analysis, and so on. And on the left hand, we can find a shortcut, to do the everyday commands for copying, moving, scaling, joining, exploding, and so on. Okay. All right. I will start by a very typical situation where we may have a DWG file, and just gonna show you how to open it simply by doing open, and I'm gonna select. Well, just take into account that within the file formats available, there are a bunch of them, and we just need to look for the DWG. AutoCAD drawing, select one of them, and then, well, we can just select the default import options, and we'll get the 2D drawing in our scene. Well, this is organized in different viewports: top, perspective, right, and front. If we double click here, we expand that viewport, but this is just 2D drawing. Okay, we take a look at the layers. We can also show and hide the layers that we have in here. Okay, and keep on working on 3D model based on these 2D curves if you don't want to create them from scratch, which is something that you can also do directly in RhinoLands. Okay, I'm going to jump to this same project, but a little bit more advanced. Okay, this is where we have already placed a few elements in 3D, but we still have of the work done. I mean, there are here a few curves that I will use to generate the terrain. I'm going to show you how to insert a few more vegetation elements. But the first thing I want to show you in this model is the edit panel. Okay, when nothing is selected, this panel shows a list of the species that we have inserted before. Of course, in an empty file, this list is empty, but from here we can select all the elements by species. So we just need to select the specific species in this model, and then we'll see them highlighted with all the attributes. In this case, we can see the different representation modes for each species, because each plant have a different representation mode in 2D, but also in 3D. We can go from elevation to conceptual, detailed, and realistic. And here we can browse, for example, for the 2D drawing, I can select any 2D crown from those that are available in the library in RhinoLands. Okay, actually, this is nothing but a 2D, well, a block, 2D block. You can create or develop your own 2D block for the plant 2D crown, and have it available in this folder and use it for the 2D representation of your plant species in the document. Because well, when nothing is selected, we can switch from these different display modes. So I can go from 3D to 2D with this button. So now the plant will show the 2D crown. Okay. Also, zones will be displayed as hatch pattern. Terrains will be displayed with contours, as we'll see in a moment. But if I select the 3D representation, I can also switch from the elevations to conceptual shape, detailed, and realistic. Basically, these different representation modes would help you to well, show the model in different levels of detail, but also for performance purpose, it could be interesting, to work only with a detailed, which might be a little bit faster, or conceptual. Okay, if you just want to show well, just some plans for a urban design, maybe you just want to show them with this conceptual mode. And as Elham has mentioned before, the realistic display mode is the one that brings the 3D geometry with all the textures, okay, on the geometry. And also this representation can handle different levels of detail. So depending on the season where you want to render this scene, we can move from spring to winter, for example, and then all the plant species will switch to their representation in winter time if they have. Okay. Well, take into account that what we see here is just a simplified representation of the plant, because when we shutter render, so we can do it from this button here, this plant would be replaced by a much accurate and realistic plant. Okay. So this is just for visualization purposes, which is already quite nice. All right. So these representation modes can be independent for each viewport. So if I double click again, we can see that from the top viewport, I am seeing models in 2D, while in the perspective, I'm using this realistic. In the left, I can use this, maybe the elevations, I can switch to conceptual, and so on. So you decide in which is the representation mode for all your project in each viewport. Okay. Now let's start inserting here a few elements. I'm going to start by inserting a plant. Let's do it here. So I'm gonna go to vegetation and hardscape tab and click on the plant command to insert an individual plant. Of course, since in this model we have already selected a few plant species, they are available from this list. But in a new document, this list would be empty. In this case, we can just click on the Browse button. So the plant database will launch. And here we can see all the species. Okay, we have more than 8,000 species in the plant database. They are all listed here, so we can just navigate through this list to see the different representation modes. We can enable these cloud images, to load some pictures for each species, or we can search for one specific one from this all these filters: characteristics, climate zones that can handle, leaf type, etc. Okay. Also take into account that we can expand this plant database by just copying any of these plant species. We just give here a new name, and then from the copy we can just edit it from the properties sheet, and well, fill all this form to, well, we need to select this edit button to create all new species based on their botanical information and details. Also here we can assign different 2D ground, conceptual, and detailed shapes. We can assign here also a realistic plant from the library. There are also over 700 or 800 different plants that can store all these different representation modes, okay, and according to season. So the idea is that you can create new plant species from scratch, or from copying an existing species. Okay. Also, this list shows some filters. We can maybe show those species that come with a render. That means that they have a specific realistic plant designed for their appearance, because not all the species have their own. most of them maybe use a one that is very close to their appearance according to the family of the plant, to the species, to the shape. Okay, so we can filter plants according to that, or we can also select plants that are suitable for vertical gardens if we want to create a vertical a green wall, or we can just search for the species from here. So we can, for example, search for a lemon tree. So I'm gonna select it from here, and I click on select. I define here the dimensions, the initial dimensions. It's interesting to mark this option if we want to insert several units, because in this case, all of them will be slightly different in terms of size from one to another, and will give us a more realistic feeling. Okay, that even though they use the same block definition, each plant will look a little bit different from one to another. Same if we activate this random rotation. Okay. Right. I click OK. So I just need to insert my plant here. And when I'm done, I can select this plant, and from the edit panel, I can modify its parameters. I can modify the size. Of course, the range of size is limited according to the species. We can also edit that if you like, or we can change that plant by another one. Okay, from the existing ones, or we can browse the plant database and pick another one. We'll get back to vegetation species, but first of all, I would like to create a terrain. So in this project, I already have a few curves. Okay, these curves are horizontal. I'm going to work, by the way, in shaded mode, so for the sake of speed. And well, these are nothing but 2D curves. Again, we can obtain these curves from a DWG file, or they could be also points from a point cloud. So basically, we can create terrains from curves, points, or a mix of all this geometry. And they don't have to be like planar curves. I can have a curve like that. And if I select this point, this endpoint, I can elevate it using the gamble. So I can use this curve as well. So basically, the terrain will try to get all the points from these curves and generate a mesh that fits with that input data. Okay. But first of all, we need to place these objects in the right elevation, because right now I have all of them in the same plane. And there is an interesting tool for that from the terrain toolbar, which is called Elevate Curves. So basically, based it on start dimension and increment, which I will set to 1. And by drawing a line, I will be able to elevate all the curves that intersect with this line according to this increment. I click apply, and now all the curves are elevated 1 meter from one to another. All right, I have the curve now in the right elevation, so I'm ready to create a terrain. I'm gonna run the terrain command. Working with RhinoLands is very simple, very intuitive, because if you run any command, you just need to follow the instructions in the command line. So here you just need to select to complete the actions that are required to finish any action, any command. In this case, I need to select the curves or points or the input data, basically. Now this insert terrain dialog appears, basically with the parameters of the terrain. Terrains are created out of meshes, so we can define the precision of this terrain from the cell size. The smaller this cell, the more accurate it will be with the input data, obviously. And we can also define the settings for the contours or the material. Actually, RhinoLands come with a material, a library of materials, so we can select any other texture from this library. Of course, if you use your own render engine with your own library of materials, you can use them as well, okay, on these objects. All right, I click OK. So I get the terrain done, okay? Just notice that the terrain has occupied this area, which is something that I don't want. I mean, I would like to trim the terrain from an existing contour. I have this contour already created here, so that's what I'm gonna do next. And there is a special command for that, terrain boundary command. So we'll again select the follow the instructions in the command line. So I select the terrain, hit enter, pick a closed curve, and that's it. Okay, maybe we can show this in rendered display mode, so we'll better appreciate the texture on that terrain. By the way, I had all these curves in a specific layer, so I'm gonna hide that layer. And also, well, if we activate the 2D representation of the terrain, maybe we can see it from the top viewport. We can see now all the contours on this terrain. But the terrain has actually a feature that lets us see it in 3D and 2D representation at the same time. So we can do this from this general tab and activating this option, okay? Which gives us a better feedback of the terrain topography. All right. Cool. Well, let's see a couple of operations we can do on this terrain. First of all, I can see I have here a curve. I'm going to elevate it a little bit because I will show you how to add a cut and fill in this terrain. So I'm going to elevate it in a way that this contour is half inside of the terrain, half outside. Okay. So imagine that we want to flatten this area according to that rectangle elevation. In this case, we don't have to put this rectangle or this boundary in the horizontal plane. It could be also inclinated to create a kind of a slope. And here I just need to run the cut and fill command, select the terrain, define the angle, how basically the terrain will meet the boundary of this curve. 45 degrees is fine. Before I select the curve, I leave this option to divide the terrain to yes. That will allow me to assign a different material to this divided area. And I select that curve. So the cut and fill has been applied. And now we can select that terrain, and we can appreciate that we have here a control arrow. So we can move the boundary of this terrain. We can move the whole area of the cut and fill from one place to another. We can also select a control point and also modify the boundary of this cut and fill by these new control points. And all this information is stored into the terrain. That means that if we select it, and from the edit panel, we can see here not only the curves that were used for initially to create the terrain, but also we can select, for example, this earth moving, the cut and fill, and maybe change the angle from the cuts and the fills. Okay, so now it's kind of a lock, but we can maybe make the fills maybe more less sharp. Okay, so all these parameters are available at any time. We can undo them by removing any of these operations. And also, since we have some changes from the original terrain with the one that we have now, we can measure the amount of volume of land that has been involved. So we will go to the documentation toolbar. We can find here this terrain list tool. So basically need to insert a list. Maybe we can see that from the top. And we can see here the area of this cut and fill with amount of fill volume and dig volume. Okay. And this is a dynamic list. That means that if we edit that cut and fill, or we add more operations on this terrain, actually I'm gonna do that right now with this curve. I'm gonna create a path. All the information will be added to the terrain. Let's do this. I'm going to add a path on this terrain. So from the terrain toolbar, I will select this path option. I select the terrain. I'm gonna define a width, so it will be 3 meters in this case, and an angle. Well, I will select also 45 by default, and finally we'll need to pick this curve. Okay, so in this case, the path is done. It has been adapted to the elevation of the curve. Okay, that means that I can now select the terrain, select the control points that have been absorbed by the terrain, and modify them. Okay. Or, I mean, of course, I can modify the original position of the original elevation of the curve, but we have several options available integrated into this terrain. So we don't need to do that. Basically, if we select now the terrain, we go to the path subdivision, and here we can also select different options, for example, to well, adapt this path to a regular grade. Okay, when doing so, I can define the percent of the grade. Let's set this to 5 degrees. Also, there are other options to define this slope. Okay, this is not, of course, the desired direction of the slope, so I can invert the curve. So this will flip the direction of the curve, and therefore I will also flip the direction of this slope. Okay, but at any time we can define how is this slope graded, either from a regular slope, from the elevation of the curve. So there are multiple options available here to play with. Okay, and we can just double check the terrain list, and we can see how this new operation has added here. So we can also measure the amount of volume of land that has been necessary to add this path. Okay. Also notice that since I created a terrain, all the elements that are placed within the limits of this terrain are automatically located on top of this terrain. If I move this plant or any other to another position of the terrain, the plant will detect the terrain and will be projected on top of it automatically. Okay, this is something that can be undone. I mean, we can set it to do not adjust the terrain and move it freely, but by default, all the objects that are located within the boundary of this terrain will be automatically placed on top of it. Okay, which is much more comfortable. Good. Well, since we have the terrain, maybe we can create a forest in that area. I'm gonna do it in the top viewport. And well, I will go to the vegetation and hardscape, run the forest command. In this case, I'm gonna select another species, maybe the jacaranda, define the approximate height. Here, I can see a new tab that will determine the parameters of the forest. So I can define the number of units, the minimum distance between each unit. I can also select this array option, but basically, this is something that I can edit afterwards, and I can either select a boundary curve previously created, or I can draw it on the fly with any of these options. Maybe I can select a polyline, and as I draw the polyline, I don't need to close it. Actually, whenever I fill it, I do right-click. The boundary will close automatically for this forest, and I can see how this terrain has been populated with all these jacarandas. Also, the forest, as well as the rows or other elements, can combine different species. So we can select here this option to increase the number of elements. When doing so, we'll get 2 different plant species hanging from this list. And now we can pick one or another and select another species, change the dimensions of them. So it's very simple to play with all these parameters. Also, there is an interesting option to clear an area inside a forest. For example, this area of the cotton field. So we go to the forest. We can also, play with this random distribution as many times as we want, or we can select this add hole option. So, well, auto saving is running. I select this curve. So all this area will stay clear from trees for this forest, no matter which is the array of it, the arrangement of the plants. Okay. And well, we can insert more plant species. For example, not only plants but also ground covers. So we can use this command, for example, to add kind of a green bed here. Also, when we browse for the plant database of plant species that are suitable for the ground covers, they are already listed here. I mean, I need to, of course, clear this list. Okay, and well, I can select any of those. Also, ground covers are displayed with a hatch pattern in 2D. And well, I could draw here also a new boundary. Maybe I'm gonna draw it in the top viewport from a rectangle. And from here I can see all these plans in 3D automatically projected on top of the terrain. They have this boundary with control points, so we can modify that very, very easily. Okay. And now we can insert a plan list. So from the documentation tab, I'm gonna select this plan list, insert it here, and in the same way as the terrain list, this is a dynamic list, so it will update live with the number of species that we have in here. For example, we can see here also the amount of this plant species that is actually the ground cover. If we select the list, we can also customize the fields that we want to show here. For example, I want to show the density for this ground cover. Well, we can also add custom parameters to this list. And also we can apply filters. For example, we would like to show only the species that are inside the forest. We want to exclude those that are in the park. Okay, so we can do this using this by region option. So I select a boundary and I can select the sim curve that we use it to trim the terrain. And now this list only shows the species located within the boundary of this curve, which is the same as the terrain. Okay, so there are many options to customize the plan list, to filter by region, also by layers. So imagine that you have two sets of groups of plants, you want to locate them in different layers, so we could also list them according to that, right? And well, I would like to show you now some hardscape tools. Okay, maybe we can insert a row of elements here. This is also an interesting tool. So we go to the vegetation and hardscape. I will run this row command. This will open this option. I mean, we can select blocks from a library. We can also browse from any other file, or we can select just any 3D element, a block in the model, to use it as an instance along this that will be repeated along a curve. But in this case, I'm gonna select the block library. RhinoLands come with this library of 3D elements. You can explore those. But I mean, they are nothing but 3D blocks in a folder. You can also add your own folder with your own blocks, that you have downloaded from the web. So it's since RhinoLands can open many different file formats, it's very easy, to integrate your blocks in your project. And well, in this case, I'm gonna select one of these lighting posts. And well, here we have all the parameters of the orientation of this post, how we want to arrange the row. I mean, how many units or the separation of them. Maybe I'm gonna set one post every 8 meters. Also, I will select, I'm gonna select the same axis that I used for the path. So I need to offset this axis to do not place the lights into the middle of the path, of course. And when I'm done, I'm gonna select this curve. The post already detect the terrain, so they're also projected on top of it. And maybe this is not the desired orientation, so I can select these elements, and I go to the sample, and I'm going to select this perpendicular to axis. Again, I'll need to invert the curve, so they face well, not in this case. I'm going to select this invert option to face the other side. Okay. And maybe we can insert a few other elements for the hardscape. Maybe we can insert a ramp in here. To do so, I'm gonna select this stair, which is a parametric object. So I can change the width to half of it. I also change the alignment. So in that other part, I will create a ramp. So from the top viewport, I will run the ramp object. Also, the ramp is defined by some parameters, so you can control the start height. The justification will be left because I want to draw it from that side. Okay. And the flight determines also the slope. In this case, is set as a percentage, but I want to define it as a height because I know that this kind of platform is 40 centimeters height. So this will determine the slope of my ramp. And well, this is the width, so I'm gonna set it to 1 meter. Also, this button is useful to measure, in place the width of the desired object, so I can see it's 150. So I'm gonna leave it as it was before. And finally, I need to draw the ramp again from an existing curve or from any of these options. I'm gonna use a polyline. Okay. Into the representation, the ramp shows this slope, but in 3D, I have only the 3D geometry, again, with a texture assigned by default. This is something that all the elements have, so I can change that very quickly from this tab. Great. Well, imagine that right now we are at the point that we need to present the document. So we will move to 1 second to the page layout. This is something that you can add from here. Those that are familiar of you that are familiar with Rhino, so you may know that we can create a new layout. Define the settings of the page, okay, size, direction, etc. In this case, I have already one page layout created, and here we just need to add details. And details are nothing but windows to the model space. Okay, we double click here, we will be able to show one view or another. Okay, we can set here if we want to set the top, perspective, and so on. And also, we can change the display mode in each viewport. So we can show that in 2D. This is like 3D, which is right. But maybe these side viewports, I want to show them as elevations, same as this other view. And maybe I can add a new detail just to show all the lists that we have created here. So from the documentation, I can add a detail. So I will draw this new window. And finally, I just need to double click and zoom to display that couple of lists. Okay. On top of this layout, we can draw 2D geometry, we can add title blocks, we can add text, we can add whatever you want and have it ready for printing or for exporting to PDF. Actually, the detailed properties also indicate the scale of these 2D drawings. So, well, in this case, if I want 150 scale, so I need to type here 1000 and here 150. But of course, this is like just too big, so I'm gonna define a smaller size. Okay, maybe 1000 will be better in this case. All right. And finally, just to finish, I would like to show some of the animation tools. There is a specific panel for that, which is the animation panel, which will help us to create quick animations or virtual tours. Take into account that we have also the wall mode, which is an interesting tool to experience your own design by putting your feet onto the project, and just with the mouse cursor, just like if you were in a video game, also with the wheel you can change the speed, you can navigate through the project. So it's kind of an interesting experience to present the project, to experience it, okay, as if you were walking through it. I click escape to exit this mode. And now we'll create a short animation. Okay. So I'm gonna enable a layer where I had a camera path, because you need to draw a curve that will define the animation path, okay? And we need to assign this curve from this pattern. We'll do this now. I can hide this object now that it's not, so it doesn't appear in the animation. Here we define the recording settings. I mean, we can define the frames per second or the total duration of it. And we can also select if we want to record the current display or use the current renderer. That means that there will be a render for each frame of this scene. So at the end, we'll get a video, a high quality video with the animation. In this case, I'm going to select just the Rhino display, which in a very quick way, we'll be able to see a preview of how the animation will look like. Okay. Maybe I need to do this camera path less curvy, so otherwise you get a little bit sick in this case.
Yeah.
But yeah, that's pretty much an overview of RhinoLands. So maybe we have some questions.
There are several questions I tried to answer in chat, but there are some of them that would be nice to show in a live demo. One of them is how to add parameters to plant species. Miguel is asking about other parameters that he wants to add to plants.
Okay. Yeah, this is something that needs to be done from the options. I mean, from the document properties. I mean, you can launch it from this icon. And when doing so, you go to document properties and you will find this parameters section. And here you can add, for example, a new parameter, for example, price. Okay. You assign it to a category. Basically, categories will define how all these custom parameters are organized. You can also create a custom one. Okay. I mean, you can also get new categories and select a data type. In this case, maybe it could be currency the most appropriate. Add some description if you like. And now when you click OK, you can select, a group of elements or individual plants. And from the properties panel, you will find this parameters section where you can add a value for this plant. Okay. And now, if we want to display this parameter in the list, we go to the plant species. I mean, this one, it's not listed. I'm gonna move it here, so it's inside the terrain, and this will make it appear in this list. And now from the list, I will. You can see here that the new parameter has appeared. So I activate this field, and I can see that this Avies concolor, so which is the only species that I have assigned a value, is displayed here.
Another fast way to do that is to export the list to Excel, because there is an export to Excel button. Once you export a list to Excel, you can add any parameters, any additional parameters that you wish.
Yeah, then it's a work in Excel, of course. Yeah. So you can do whatever you want, but you can export the list also from here.
And then another question about how you can list the material. The material, basically, if you mean the surface, I mean the different pavements and different surface material, we do that through Zonify. So once we zonify our project, actually we get the area of each zone and we assign a material. So in that part, you can assign a specific material for any surface, any pavement, and finally calculate the area of those pavements, and also for paths, because we can list the path, we can list the ramp, and we can list the stairs. So finally we get the quantity of all these areas. For example, in this case, we have also a ramp, I guess, right, Francisco? So here we see that the area of each zone and the name of the zone, which could be the material as well. Another question about the scale. How would you, for example, the scale of 1 to 20 or any other kind of scale?
Yeah, that's something that is in the properties of the detail. So you select the detail, and here you define the scale of it. So, for a 1 200 scale, you will need to type here that 1,000 millimeters on the page is equals to 200 scale. Okay, that will be the way to assign a scale for the 2D drawings in your page layout.
Well, about the translation of the program is available in French, Italian, Spanish, but not in Portuguese, unfortunately. So I hope you can use it in any other language that you prefer, rather than English, or in English. And then there's a question about how they can filter a list of plants based on trees, shrubs, and so on. One workaround is that to place all shrubs in a specific sub-layer or list.
Yeah. So it's not possible to filter plant by type. I mean, let's call it by type. Understanding that shrubs are one type and ground covers are another type. But yeah, if you put all these plants in different layers, so you can choose this option to maybe show only the plants that you have put in the layer shrubs or in layer ground covers.
There's another question about the changing the language, how we can change the language.
Yeah, you can change the language from the options. I mean, from this giant icon here, and you can just change the. I mean, here this is the same dialog as you can find in Rhino, but you go to Appearance, and then you select here the different language, or you can just go to Land Design, and here by default is the same as Rhino, and maybe you can have Rhino in one language and Land Design in another. Okay, but I mean, this is the easiest way to change the whole interface in one language.
Another question is to have a short just overview of the items that we can list after designing. So let's just review the items that we can list, please.
Yeah, basically we can list plants, we can list blocks, fences, walls, paths, zones, sprinklers, pipes, and terrains. These are all the elements that you can list.
And about how we can define pavements, they are zones. You can indicate a zone as a pavement.
Yeah, basically zones are created as hatches. Let's maybe, for example, create one here where, sorry, we can run this command. The
Zonify.
We run this command, the zonify command. We can pick an empty point within an area, or we can use this option to select an existing boundary. This one, and we select a name for the area, also a hatch pattern, and okay, I think I picked the wrong boundary. So let me do it again. Or maybe we just pick this area inside. So I select the building. I can maybe change another hatch pattern. Okay. And finally, insert the label. So
you will see,
yeah, I mean, in 2D representation, this is represented with a hatch pattern. But if I switch to 3D, I will see the material that is assigned. I mean, I need to select this to rendered mode, the material that is assigned to that surface. It's actually a textured surface in 3D and a hatch pattern in 2D representation. And from here, we can change the material.
Well, the shape of a surface can be a polygon. Yeah, a polyline, of course. Miguel is asking.
Yeah, any shape.
It should be a closed polyline. Any polyline, any shape that you want, but a closed one.
Correct.
I don't know if there's any other questions. I think we could. Okay, so the last question is about the irrigation plan. if we can see or take a look at the irrigation system, but
Yeah, I'm gonna move into the. So the tools of irrigation basically are those for inserting sprinklers that can be inserted individually, or we can insert them in an array. I mean, we need to select the boundaries. There are several blocks for the sprinklers, and we can select from these different types. And well, the radius also determine the 2D representation of them. So now I can select a boundary curve. So we'll have all these sprinklers automatically created here. And I mean, of course, later on I can select them. I can change the symbol. I can change this, well, this radius. Okay. And they will adapt to the boundary if we modify it through the control points. And we can list them. Also, there are lists for sprinklers. There is also a pipe tool, which basically generates 2D lines. It doesn't have a 3D representation, but it generates 2D lines to connect sprinklers, and they can be created from an existing polyline that you draw, but it will be aligned with some data. Okay, for example, the pressure or the diameter of the pipes that we can also list afterwards.
Antonio is asking about, is it possible to make construction details from defined materials? No, this kind of details are not available in RhinoLands of
Well,
machine.
actually it is, but
Mhm.
I mean, it's just a manual work. I mean, here you have all the 2D drawing, and 2D tools to generate any kind of construction design in 2D. I mean, we could generate a section and maybe on top of it, draw all these construction details. But I mean, all the 3D elements, they have a very quite simple level of detail. So they are not, let's say, aimed to produce construction details. So we'll basically end up creating them with, manually with 2D tools.
Are asking about how they can change the color of layer in different viewports.
Well, that's related to the display mode. Okay.
I mean, for
but-
example, they want to create a plan of existing versus a proposed one.
Okay. I'm afraid this is not possible, I would say. Correct me if I'm wrong.
Directly, because they can make a copy of the same design, save it as a new file, and change the layers and produce that. I mean, you will have two copy of the same project.
Yeah, it's true that the plant species, they have the block has a color by parent, so we can change the parent of the planting and or the species, and they will show in one color or another. Okay, so we can show them in blue. In well, they should show in blue. Maybe it's the print color. Well, we need to figure out why it doesn't show in blue. But yeah, I mean, these same plant species can't show in two different colors. So you should create a copy of it.
Yeah. Also, there's a question about generating a lake in RhinoLands. Basically, if you import a topography, or if you have topography and you generate a terrain, you know the location of the lake. So it's the matter of having a closed boundary and generating a flat surface. So it's by using
Exactly.
surface command in RhinoLands. You need to have just the boundary of the lake on top of your topography. But if you are starting from zero, you have no topography, first you need to generate the topography or the terrain.
Exactly. And there are methods also to calculate the intersection between a terrain and a surface. So you can obtain the contour. And with this contour, you can generate a surface maybe for assigning a material of a water. Okay. So that's the way you could do it.
I'd like to share my screen again to show just a quick view of the
All yours.
website. Yeah, thank you. So here is the download page of RhinoLands. I mean, rhinolands.com/download. And when you go to download page, you will see RhinoLands as the first option. If you want to use AutoCAD version, I mean, if you have already AutoCAD installed, you can try Lands Design for AutoCAD. It has most of the features that you have seen today, but in AutoCAD environment. And if you prefer the original interface of Rhino, if you are a Rhino user, you can use Lands Design as a plugin for Rhino. But for new users who have no knowledge of Rhino, the RhinoLands is the perfect solution. You will have 60-day free trial, and then you will see that how is the licensing and how are the pricing options for students, for schools, and so on. For example, in the case of lab license, this price is for a permanent license and for the use of up to 30 users at the same moment. So this is quite useful. And you can take a look at our project gallery. So you will see that in different scales, the program is used from small scale to larger scales like these. And also you can take a look at our features. So you can overview any kind of features that you are looking for. For example, if you are keen about specific tools in documentation, you can directly go to documentation and see how are the features. And the last but not least, feel free to contact us. You will reach out to us. This is our email, rhinolands@asuni.com. And you will have the recording of this session, of course, in a few days after this session. And for any other questions, just feel free to contact us or just look for the support page. There's a user's guide quite recently published. Also, in our YouTube channel, we have a specific, let's say, a specific new set of video tutorials, which is tutorials of RhinoLands tutorials. You will see that you can start from a beginning until the advanced level. So you can follow these 7 tutorials and you will get to an intermediate or advanced level of the program. Depends on you. So just this. Thank you to the Portuguese
have a
Association
question.
of Landscape Architects.
Can I ask you something just
Sure.
before we go?
Sure.
Last year, you offered a special discount for APAP members. Do you continue that?
Thanks for mentioning that. Yeah, of course. I forgot to tell you that. But yeah, that discount is available, is valid for all members of Portuguese Association of Landscape Architects. You will have 100 euros of discount on commercial licenses, of course. Thank you.
Perfect.
So thank you everybody for joining this webinar, and feel free to contact us for any other issues or concerns. Thank you, Francis.
Thank you very much.
Thank
Muito
you,
obrigado.
Maria. Bye-bye.
Thank you. Thank
Bye.
you so much for presenting this to us, and thank you to everybody who came and participated.
Thank you. Bye.